Morning, everybody. Tony Jones here from Financial. Thanks for joining us again for our weekly broadcast. Good morning, everybody. It's Tony Jones from Bravo Financial. Thanks for joining us for our weekly broadcast. Today we have a great local guest in Tarik Yousef, who has really built a new ventilator. And so that's what we're going to talk about, what the problems that we've had and the needs that we've had and how you're helping to address that and the problems that we have. So the first thing I want to do, you're from Columbus. You have your own fine furniture business, TY Fine Furniture. But tell me a little bit, not anybody could just start to make a ventilator. You have some design, in your system. So tell us about your background.
So I'm a mechanical engineer. I went to school at Ohio State. I spent the first chunk of my career at Honda as an engineer designing tooling for their production. And I switched gears over into the wood furniture business. We're a little different because I started that business. We've kind of hit it from both sides in that I started the business just with hand tools, purely hand tool, handmade, bespoke, ultra high-end furniture. And then now we do a lot of actually automation and techniques. We really know the gamut of how to make a product and how to make something properly. The ventilator came out, there's a need, and I happened to be working with the exact controller and touch screen and everything that I felt was perfect for a ventilator. And so it became are you just going to sit around? Or are you going to take this thing that you might be the only person in the country working with this specific device in combination and do something with it and try to do something good with it?
Right. Well, before we get into that, let's talk about the actual need for ventilators. And better yet, why do we need ventilators? Who are they helping? What problem is this helping?
Well, with COVID-19, there was a severe shortage issue. About 2 months ago, the projection was 1 million units were needed, and the U.S. had 16,000. And all the U.S. manufacturers were like, we're going to ramp up and we're going to make more overnight. And I'm like, well, you guys make 1,400 a year. So what's ramping up?
Right.
1 million. And then you had automakers saying they're going to do it. Well, I used to work at Honda. I used to be an engineer in auto. And I know the timelines. I know how long it takes to tool up. I know how long it takes to get a product through that process. And I just couldn't fathom it actually happening in a reasonable time frame.
Right. So basically we need this component that is putting more oxygen into our bodies and getting rid of carbon dioxide, right? Is that in its
mostly? Yeah, there's two forms of ventilators really. One is a patient is struggling, they're conscious, they're in good shape, they're in reasonable shape, but they do have a respiratory problem, and it helps them. It just helps them breathe and helps them get air into their lungs. And then there's a second type, which patient is unconscious, and they're more critical, obviously, and they cannot breathe. They have no ability to breathe, and the ventilator is the only thing essentially keeping them alive.
And so your unit that you've designed, does that apply to both problems?
It actually applies to both, which we're possibly the only emergency ventilator that actually can do both sides of the spectrum.
And it seems to me it's a pretty simple. The concept of the unit is really pretty simple, right? You need to monitor what needs to be done, which a lot of them don't necessarily do that well either.
Right.
But I'd imagine that we really haven't had an impetus to do anything differently over the course of time. Until now, I'm just seeing a lot of innovation. Are we seeing differences now in the ventilators compared to?
Yeah, original ventilators, the average ventilator in a hospital starts at about $16,000 and goes up $50,000, $60,000. They are chock full of bells and whistles and features and all sorts of stuff, right? Most people you talk to, they're kind of like, I don't know what that does. I don't know what that does. So there's a lot of bells and whistles that even the people using it are kind of like,
they never need it.
They don't need it. They're kind of like, and certain models they'll even say, yeah, this model, I don't use that feature on this model because it doesn't work well, or I don't use this model, So most respiratory therapists and pulmonologists are like, I use 3 features on this model, for instance, mostly. And so the units have gotten overcomplicated, a little, kind of fat and lazy, and they're just not doing, they're not appropriate for the emergency aspect of what we're up against.
Yeah. So even if we get past this, kind of flattening the curve in the U.S., I bet other countries, less established countries, probably will have still a great need for something inexpensive and, easier to manufacture and such.
Financially, it's a big issue for most countries. We're lucky in the U.S. because if we need something, we get it. Mm-hmm. I have a friend in Mexico, his mom needed a ventilator. Before all this happened, she needed one, and all this happened right when she needed it. And in Mexico, the ventilator she needed was $20,000. In the U.S., that same ventilator was $5,000. So he ended up buying the ventilator in the U.S., flying to Mexico to deliver it to her. But that shows how much of an advantage we have in the U.S. and how bad it is in other countries, and how big of a deal it is when people might live off. Not in Mexico, but in other countries, $5,000 might be what you make in a year.
Right.
And you're saying, oh, well, you need 4 years' salary to pay for this life-saving device. It might not be feasible.
Right.
So,
yeah. So hopefully that's what comes from this.
Exactly.
As we get through this. So, talk a little bit about. We have a picture here of the unit, right? So let me. Oh no, I'm looking. I want to.
Yeah.
I was right. Yeah. So, where should I go? Home.
Home. Yeah. I think it's on the home page.
Okay. Come on, go out there.
Right.
Sorry. Here we go. Okay, so, and you can, there's a number of places, if you go to YouTube, you could Google your name and you'll see the ventilator. Some folks can do that. But basically, obviously, this looks a lot simpler than what we might see in a hospital. As you said, it's probably hitting most of the functions that are necessary to people. But talk a little bit about the manufacturing process. How are you able to transition from what you do with woodworking and such to be able to do something like this?
Like I mentioned earlier, I was already working with the controller. I was already working with the touch screen. I had a good relationship with the company that manufactured those parts for another project. And actually, those parts were the perfect parts for this product. Our unit uses what's called an ambu bag. It's an emergency resuscitation device that is in every hospital with every hospital bed. It's very common. It's sterile. It's clean. It's FDA approved. Mm-hmm. So we take this thing that's very clean, very approved, and with COVID, that's a big issue because just the idea of using a ventilator that someone else has breathed through who's been sick or more sick is kind of crazy to me. So I want to throw out anything and everything that's been involved, and so do doctors, and that's how they feel about it. And so with this, you can take that bag and the hoses and everything and get rid of it when you're done. And so the idea is, it seems simple at face value, but it pumps that bag mechanically with an arm consistently. But it uses a lot of sensors, a lot of technology. There's an incredible amount of sophistication in the device in order to deliver a breath safely, at the right rate, at the right flow, volume. And the bigger thing is, our goal is for a patient to get better, right? We're not just trying to put them on life support, we want them to get better constantly. And so, to help them get better, your device has to be very flexible and very smart. Every breath it changes. Every single breath it delivers is slightly different than the last. And the goal is to improve the patient's breathing, allow them to start breathing on their own, allow them to build up those muscles again, and recover. Right.
So I'd imagine if you had everybody who needs these at one time in a hospital, They all need to work a little differently depending on the breathing patterns of the individuals.
And what I as a patient would need today is not what I need tomorrow.
Yeah.
To boot. So when you heard about people splitting ventilators, that is life support. That is, that is adding days to their life. It's not having them survive necessarily.
Because really they're both at that getting the same pace of oxygen and things like that possibly, right?
Yeah, you're dumbing it down so badly that you're just barely keeping them alive at that point if you're doing something like that. So that was the point of the device. You mentioned manufacturing. We have CNC routers and some pretty sophisticated equipment. And our goal with this device was to make essentially a tooling-free product, something that another shop with a CNC router, which is a pretty common item these days in a lot of wood shops and manufacturing facilities, something where almost any facility could make it without needing a $50,000 tool and 6 months to develop that tool and a $1 million injection press to pump out the parts. Our biggest concern when we started this, and it's become a bigger concern than even I imagined, is parts availability. What can we make that parts no one's using, parts that are readily available, parts that we can make ourselves, so we don't have to rely on a vendor across the world that might be shut down or might not be able to ship this week, or
Right. I mean, the ingenuity has been great. That's what if anything good has come from this, I love seeing that. Speaking of which, the open source, right? I mean, you're sharing your information and trying to gather out there. Have you learned anything from others, and what has that been like sharing the information?
I follow a few groups. I've talked to some doctors and other people around the country who are working on similar projects. The big thing I've taken away is everyone's doing it their own way, and everyone kind of has to, because the reality at the end of the day is the controller in Germany isn't the controller in the US, isn't the controller available. The motors available in the US are different than the motors available in different countries. So everybody's come up with their own flavor of device. And, as long as you're doing what you need to do safely and smartly, there's nothing wrong with it.
Yeah.
But the big issue is just, that is the issue, right? And it comes down to supply chain, ability to get parts.
Yeah.
When we're all said and done, this design goes out in the world, and it's just going to be readily accessible to anyone. Our hope is that we can essentially do a free license to facilities that are fully capable. We don't necessarily want these being made in someone's garage, but we want to work with people and help them produce these devices safely and at a real scale.
Okay. So a couple more things. One is, this is probably the first time you've had to deal with the FDA to get this product approved, because you're still not able to manufacture it. And I'd imagine, I think government agency, so without getting too much, when can you expect, what kind of time frame is it typically when you go to them and try to get this approved?
So there's an emergency use authorization, which actually the FDA is approving devices. Usually it was 120 days between every communication you had with the FDA, which means you send them something, they have 120 days to respond to you so that you can respond to them. And so it was this incredibly long process. Now it's 72 hours, 3 days. So it's an incredibly fast process. The catch is, and anyone can essentially approve anything if they want, the catch is they've essentially said, you don't have to test if you don't want to test. You don't have to do this if you don't want to do that. But then there's a moral obligation to do the right thing.
Right.
And so there are devices that have, a lot of doctors have said it, they're like, all this stuff's getting approved and none of it works. I'm like, and the funny part is the FDA regulation says nothing about it working.
Yeah.
It can't electrocute them, it can't shock them, it has to be waterproof, it has to be this and that. Nowhere in there is this is a working device.
Right.
And so a lot of things are getting approved that just simply don't work.
Yeah.
And the whole point is it's up to you as a, as a person, as a manufacturer, as a, to do the right thing.
Right.
And so we, from the beginning, we said we're going to test. Whether we have to or not, we are doing all the testing that we can do reasonably. Yeah. And again, our goal isn't for publicity. It's just to make a good device that can save lives. That's it. End of story.
So to do so also, it takes money and things like that. So let me shift gears here. Yeah. So 2 ways that people can help, and that was part of this, is you could donate from the COVID-19 ventilator.org website. That's one. You could also go directly to GoFundMe, because you guys have a page there.
I do.
I think that's, so you could, COVID-19 ventilator open source project. And
correct.
You can come here. You can see anybody who's looking, we're shy of the goal here, so we do need, some donations to be able to do this. So,
yeah, I've used a lot of my personal money to get the project going. We are flying through money. It's an incredibly expensive process. Every bit makes a huge difference, of course. And I see it as $1,000. That's a ventilator, right? That's literally a life saved for a pretty nominal amount of money.
Right. And we certainly need them. So go there. You can go to, again, COVID-19ventilator.org. But anyway, anything else to add? I appreciate you coming in. And this is awesome. What you've done here, just a great example of what the good that we could have come from things like this, and the caring of people to help people. So anything else to add?
I want to thank all the volunteers. We've had people volunteer from all over the country, tons of people locally, almost too many to mention.
Sure.
But, the efforts Amanit and Liz have made towards the project, especially even Carlin, who's been helping us with the manufacturing and development. Incredible efforts. And then we've just had so many people volunteer. It's incredible. And the list is very humbling to see how many people really want to make a difference.
Well, that's awesome to hear. So thank you for your efforts and all that you do. And then on the side note, it looks like awesome furniture. So go to TY Fine Furniture as well and check that out. So, but thanks for coming in. Thanks everybody for joining us as we wind our way to opening things up. Please be careful out there, and we'll see you soon.